Section 3.6, rational functions. A rational function is a function where you have a polynomial over another polynomial. The most basic would be 1 over x, which the graph is right here. We're going to refer back to this in a minute. A unique feature of rational functions is asymptotes. Vertical asymptote is when y goes to infinity or negative infinity, when x goes to a certain point from either the right or the left. And you can also have a horizontal asymptote if y goes to a certain value as x goes to infinity or negative infinity. So for this graph, a vertical asymptote is just like a line, like a vertical line or a horizontal line, depending on the asymptote. And it's just an imaginary line that the graph approaches but doesn't touch. So here we have a vertical asymptote because x gets closer to it. As x gets closer to it, y goes to infinity. Or in the other direction, as x gets closer, y goes to negative infinity. There's also a horizontal asymptote. And as the y value gets closer, x goes to negative infinity, or x can go to positive infinity for the other direction. So to find the domain, that's the first step to graphing. So for that, you just set the denominator equal to 0. Next, you will find the horizontal or slant asymptote. A slant asymptote is basically the same thing, but it'll be y equals something with a slope. To do that, we're going to divide the numerator by the denominator. The numerator goes inside, the denominator goes outside. And then the answer is the asymptote. Before you can do anything else, you have to reduce the function, so you have to factor and cancel. Then you'll find the vertical asymptotes by setting the remaining denominator after you cancel out equal to 0. Then find the x-intercepts by setting the numerator, the top, equal to 0. Plug in 0 to find any y-intercept. And then you can also make a table to get more points. Normally we'll do 3 on each side of the asymptotes. So for this graph, 2x minus 1 over x, first we're going to find the domain. So we're going to set the denominator equal to 0. So the denominator is x. X equals 0. But really what we mean by doing that is it can't be 0. So our domain is everything except for 0. So negative infinity to 0, union 0 to infinity is our domain. Next we're going to find our horizontal or slant asymptotes. We'll do that by dividing the numerator by the denominator. Numerator inside, denominator outside. So 2x minus 1, the numerator inside, denominator x on the outside. We could do synthetic division for this if you wanted to with 0, because it would be x minus 0 would be the denominator. But 2x divided by x is just 2. Multiply back is 2x. Subtract. Bring down our negative 1. Negative 1 cannot be divided by x, so that's just our remainder. but the remainder does not matter. So y equals 2 is our asymptote. So since there's no slope there, it'll just be a horizontal asymptote at y equals 2. So we'll go ahead and draw it. Then we will factor and cancel to reduce. Nothing factors out of either, so it's already reduced. I'll just rewrite it. And we'll find vertical asymptotes. You do that by setting the remaining denominator. If anything reduced away, it'll change. But set the denominator equal to 0. So we have a vertical asymptote at x equals 0, which is the y-axis basically. Then we'll find the x-intercepts next. Find the x-intercepts by setting the numerator equal to 0. Our numerator is 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. That's our x-intercept. So you can put a dot. You can find our y-intercept next. Plug in 0, which we can't do. It's not in the domain, so skip that. You just write none, no y-intercept. And then we will make a table to get a few more points here. Usually it's a good idea to take 3 points on each side, so our asymptote's at y or x equals 0, so we'll plug in -1, -2, -3. And we'll also do +1, 2, and 3. So our function's written right here. We can plug it into that. 2 times -3 would be -6 minus 1 over -3. So it's -7 over -3, 7/3, just over 2. So at -3, it's just over -2. Next, we'll plug in -2. 2 times -2 is -4 minus 1 over -2. That's -5 over -2, or just 5/2, so that's 2.5. -2 go up 2.5. And then plug in -1. 2 times -1 is -2 minus 1 over x, which is -1. -3 over -1 is just 3. So -1, 3 is our point. Do the same thing for the other side. Plug in 1. 2 times 1 is 2 minus 1 over 1, which just equals 1. Plug in 2. 2 times 2 is 4 minus 1 over 2, so that's 3 over 2, which is 1.5. And last, let's plug in 3. 2 times 3 is 6 minus 1 over 3, 5/3, which would be 1 2/3. So we can see with these points, we have a pretty good idea of what our graph's going to look like, so go ahead and plot it. And it goes really close to the asymptote but doesn't touch. Has to connect through those dots. something like that.